So good morning. So today we are going to see about electronic fuel injection system. So that is used in internal combustion engines. Okay, EFI. Shortly, it is called as EFI, electronic fuel injection system. And what is the need for electronic fuel injection system? Okay, so the contents we are going to see based on this topic EFI, electronic fuel injection. So we are going to see the introduction part, air induction system, input sensors, that is what are the sensors that are integrated with the electronic fuel integrated system, ECU, electronic control unit or electronic control module. So which is a mini computer which is going to receive signals from various input sensors. So the next one is the output. So in the output we are going to see the actuators, fuel delivery system, advantages as well as disadvantages. So in the introduction part, the electronic fuel injection system fitted to most modern vehicles combines sophisticated computer controls with a high pressure fuel delivery system to provide optimum power and fuel efficiency. So it uses the electronic sensors for precise metering of fuel. Okay, so for precise metering we need electronic sensors. So the system is controlled by electronic control unit. Okay, so all these electronic sensors will give signals. Okay, will receive signals from various engine parameters, so that will be processed by the ECU. Okay, so replacement for carburetor. What is the need for replacement of carburetor? So non-engine vacuum is used to feed fuel into engine. Okay, so next, pressure is used for electric fuel pump. Okay, so this is a this diagram indicates a typical electronic fuel injection system with various sensors. So you can see the fuel injector. So this is the fuel injector. So this is the ECU. So we are having various sensors: pressure sensor, temperature sensors, crankshaft set position sensor, camshaft position sensor, exhaust sensor. So all these sensors will be receiving signals from its corresponding value. So and the signals are sent to the ECU. So the ECU process the signal and the signal is given to the injector, fuel injector. Finally the signals are given to the fuel injector to vary the injection or to control the injection. Okay, so this is how electronic fuel injection system works. Okay, so the types, now we are going to see the types of electronic fuel injection system. The first is the single point injection system. So the single point injection system, it was used in earlier internal combustion engines. Multi-point injection system, next comes the multi-point injection system. So in recent technologies or recent engine technologies, we are using this multi-point injection system. Okay, so next we are having direct injection system and indirect injection systems. So all these four types of injection system comes under the category of electronic fuel injection system. So next is the single point injection system. So it is also called as TBI, that is throttle body injection systems. So as the name implies, it is a single point injection system. Okay, so irrespective of the number of cylinders, the engine is provided with a single injector. Okay, respective of the number of cylinders, the engine is provided with a single injector, and the injector is normally placed above the throttle valve. Okay, so that's why we call it as a throttle body injection or a single point injection. As the name implies, it is a single point injection system. Irrespective of number of cylinders, it is provided with a single injector. Okay, so here the ECU controls the injector opening. Okay, ECU controls the injector opening. So when the injector should be opened for injection, it is decided by the ECU. How it is decided by the ECU? By receiving signals from various sensors. So next is the multi-point injection system. So in multi-point injection system, each and every cylinder possesses its own injector. Okay, suppose it is a 4-cylinder engine, all the 4-cylinder possess its own individual injector. Okay, so what are the drawbacks? that we experience in throttle body injection will be eliminated in multi-point injection. In throttle body injection, since it has a single injector, with the help of single injector we cannot distribute even amount of fuel to all the cylinders. Okay, but in case of multi-point injection system, such drawbacks can be eliminated because each and every cylinder is provided with its own individual cylinder. So that is the main advantage of this multi-point injection system. In recent engine technologies, all the automobiles are equipped with a multi-point injection system under different names, that is CRDA, distributor type, unit injection, likewise. Okay, so in case of multi-point injection system, the injection is the the ECU, electronic control unit. As you all know, the electronic control unit receives signals from various sensors. Okay, so next one is the direct injection. So in direct injection is an example of multi-point fuel injection. So here the fuel is the injector. Okay, with the help of the injector, the fuel is injected directly into the cylinder, that is directly into the combustion chamber. Okay, so here you can see, okay, fuel is injected above piston head, small combustion space, better thermal efficiency. So these are the advantage of this direct injection system. So the other example for multi-point fuel injection is the indirect injection. So in indirect injection, the injection takes place in a pre-combustion chamber or a swirl chamber. Okay, pre-combustion chamber or a swirl chamber. Okay, a small chamber will be placed above the cylinder main combustion chamber. Okay, initially the injection as well as combustion develops in the swirl chamber, then through the swirl chamber and the main combustion chamber will be connected through an orifice. Okay, as the combustion develops in the swirl chamber, when it passes through the nozzle, okay, when it passes through the nozzle, uh, gas velocities are developed, then it enters the main combustion chamber. Okay, so this is how a combustion and injection develops in a indirect injection system. So the main disadvantage or advantage in case of indirect injection system is high compression ratio needed to aid starting. Okay, so we cannot call it as advantage, it is a drawback. Okay, higher compression ratio needed to aid starting. Okay, for starting purpose we need very high compression ratio. Okay, so next is the conventional carburetor engine. So this particular figure shows the conventional carburetor system. Okay, so as we all know, in a carbureted version, so the fuel is intake by the engine due to its vacuum, due to the vacuum created inside the cylinder engine. Okay, according to the vacuum, the fuel is drawn, okay, into the engine for combustion purpose. So here the carburetor, as the carburetor we are using in the earlier engines, we used the carburetor. Since it's a mechanical device, to a period of operation its efficiency is going to get increased, as well as for varying operating conditions. Since it is a mechanical device, it is unable to provide, okay, the carburetor is unable to provide mixtures according to the engine operating conditions. Okay, as we all know, for different operating conditions we need different air fuel ratios. Okay, we need different air fuel ratios, so that different air fuel ratio or mixture conditions, okay, different mixture conditions or different air fuel mixtures is unable to provide by the carburetor with quick response as the engine operates. Okay, so for this purpose we are switching from carburetor to injection system. Okay, so in conventional carburetor system, how the induction system works, we are going to see how the induction system works. So the air induction system consists of air cleaner, airflow meter, throttle valve, air intake chamber, intake manifold runner, and intake valve. So these are the components that are present in a conventional carburetor engine. So when the throttle valve is opened, air flows through the air cleaner, through the airflow meter, past the throttle valve, and through a well tuned intake manifold runner to the intake valve. So the point mentioned here, it is clearly shows that, okay, so the intake in a carburetor vessel is purely by means of the vacuum, whatever the vacuum that is produced inside the engine. Okay, so otherwise we call it as natural aspiration. Okay, so here the volumetric efficiency, there is a risk of reduce in volumetric efficiency, so that can be overcome by the electronic fuel injection system or injection system. Okay, and that's all for today. Thank you guys. Thank you.